Hey guys, welcome back to another video. Today we're doing another UKMT question. So the question is, the diagram shows the regular octagon. What is the ratio of the area of the shaded trapezium to the area of the whole octagon? To make it easier for ourselves, we'll draw the diagram again. So we have our top there. And then there. And then we have our trapezium, which is shaded on the top, like that. So we can split our octagon up into various shapes, so then we can figure out the area from there. So we can make another trapezium that goes here, and you can draw a line from one of the vertices down and the other vertice down. Okay, so a point to note is that we know that so if we label our vertices, so A, B, C, D, E, F, G, H, AD and HE and CF and BG are equal parallel lines because it's a regular octagon. So therefore, when we see that we have our right angle triangles here, these two sides will be the same. So these are isosceles right angle triangles. Right. So using so we can find the area of our shaded trapezium first to make it easier. So to find the area of a trapezium overall, it's a plus b over 2 times height. We don't know our a or b, and we don't know our height either. But we can find that out using our right angle triangles that we have. So using Pythagoras' theorem, so we can assume that the shorter sides are 1. So we would say that 1 squared plus 1 squared equals our c squared, which is basically 1 plus 1, which equals 2. So our c squared equals 2. So then our c would equal root 2. So then if CD equals root 2, then because it's a regular octagon, then all our sides equal root 2. And that equals root 2, and that equals root 2, alright? So then we can find the area of our triangles here, and then we can also find the area of our rectangle, which is in the middle, if we've assumed that this is 1. Okay, so then our area of our triangles, our right angle triangles in our trapezium, so we have 1, 1, and then root 2, so base times height, so 1 times 1 over 2 times base times height over 2, just base times height over 2, which is just half. So if half of a triangle is half centimetre squared, then both are going to be 1 centimetre squared. And then we have our rectangle, which is in the middle, which is basically root 2 by 1, because 1 is our height of our triangle. So that would just be root 2. So then our total area of our shaded trapezium would be 1 plus root 2. So that is the area of our shaded trapezium, which we'll use to find the ratio between our whole octagon. So if we know the area of our shaded trapezium is 1 plus root 2, then we know the same trapezium here would also be 1 plus root 2. And then our area of our rectangle, which is in the middle, would be 1 plus root 2 plus 1, which is 2 plus root 2, multiplied by root 2, which is the height, which is also the side of DE and AH. So you basically have plus root 2 times root 2. So root 2 by 2. 2 by root 2 is 2 root 2. And then root 2 by root 2 is 2. Plus 2 root 2 is the area of our rectangle. So 2 plus 2 root 2 plus the area of our shaded trapeziums, which are 2 times of 1 plus root 2, plus 1 plus root 2. So that is basically 2 plus 2 root 2. So you have, so that basically equals, so 2 plus 2 root 2 plus 2 plus 2 root 2. Plus 2 is 4, and then 2 root 2 plus 2 root 2 is 4 root 2.
Yep.
Like that. And then we can, so that is the area of our whole octagon. So then we would do the area of one trapezium, shaded trapezium, which is 1 plus root 2, ratio to 4 plus 4 root 2. So over here we can factorize 4 plus 4 root 2 to have the same kind of multiple. So we can, so the common factor in this is 2. So it'd be 2. And then we would have 4, sorry. 4 is the common factor. So it would be 1 plus root 2. And then we have 1 plus root 2 here. So we can divide both sides now by 1 plus root 2. Which would just be 1 and then 1 to 4. So that is our ratio. Thank you guys for watching our video. Please make sure to like, comment, and subscribe, and we'll see you next time. Bye.